Hello, everyone. Today we are going over side angle side postulate. So yesterday we talked about one way of proving triangles congruent is using side, 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 which is to show all the sides of one triangle are congruent to all the sides of another triangle. So today we're going to talk about using this thing called side angle side. Now, the important part of side angle side, or SAS, is if two sides and the included angle of one triangle are congruent to two sides and the included angle of the other. So the included angle is this important thing. So when we look at our diagram here, you'll notice that the angle I'm talking about is made up of the two sides that I know are congruent. So it's this angle that's in between. It has to be the included angle. So now let's talk about some examples. So what additional information is needed in order to prove these triangles are congruent? So when I look at this first one, I know that TQ is congruent to RS. Then if I remember the reflexive property, I know QS is congruent to itself. So what I would need to know is I need to know that that angle in between, so this angle here, which is TQS, is congruent to angle RSQ. I need to know those two angles in order to prove these triangles are congruent by side angle side. Now to write the congruent statement, that's where I have to put my triangles in the same order. So T would match up with R. Q is going to match up with S. And then when I go the other way, S matches up with Q. So it would be triangle TQS is congruent to triangle RSQ. So now when I look at this second example, what I would need to know is I need to know the other side of my angle is congruent. So I would need to know that HI is congruent to LN, which would be the other side of my angle, because I always need the angle to be in between the two sides. And that would give me triangle GHI, because GH is the single, is congruent to triangle MNL, because MN is the single. Draw a triangle and label the vertices A, B, and C. Okay, so we're going to draw a triangle, A, B, C. What angle is between BC and AC? So I want you to pause and I want you to answer these four and then come back. Okay, so now number one, what angle is in between BC and AC? Well, here's BC, here's AC. So the angle that's in between them is C. Notice how C is in both names. What sides include angle B? Well, angle B, oops, I don't want shapes. Just want to change color. Angle B is down here. So when I draw angle B, I get BC as one side and AB is the other side. Notice how B is in both those. What angles include AB? So AB is the side down here. So the angles that include AB are angle A and angle B. It's the two ends of the included side. And what side is included between A and C? Well, AC is that blue line that I still have there. So that would be AC. So now, continuing on. So now decide whether you can use SAS to prove the triangle's congruent. If so, write the congruent statement. If not, right, not possible. So number 5, I have AB is equal to BC. And I have these two angles up here. So what I need to remember for 5 is that BD is congruent to itself. So this one is a yes. And then I'm going to use my colors. So ABB, triangle ABB. So I went blue, green, pink. So I'm going to go blue CBD. Now when I look at number 6, this angle that I have congruent is not formed in between my two congruent sides. It's down here. So one side is the side I know, but the other side is not. So this one is not possible. So I want you to pause, and I want you to think about 7 and 8, and then come back. Okay, so when I look at 7, the right angle, I know right angles are always congruent to other right angles. So this one is yes, because I have pink is congruent to pink. Blue is congruent to blue. And the angle that I have is one pink side, one blue side. So that would be triangle. And I'm going to use my colors again. CDE is congruent to, I did pink to blue, FGH. Number 8, here again, I have JK is congruent to ML. Those are blue. I have these pink angles. M is congruent to K. And then MK is itself. So this one is again yes. And again, I'm going to go in order. So blue, pink, green gives me triangle LMK is congruent to triangle JKM. Okay, now number 9, the only thing that's labeled on 9 is the right angle. So I do know I have two right angles, and I know this side's congruent to itself, but that's all I know, so that's not possible. Number 10, I don't have any angles labeled. I do know that this angle is congruent to this angle because of vertical angles. However, that angle is not in between my two sides. So that one's also not possible. Okay, so now we've got a couple of proofs we're going to try. I'm actually going to do 2 in the video, and then we'll do 12 and 13 together tomorrow. So number 11, supply the reasons in this proof. So the first reason is these are given. I know that AB is congruent to DC, and I know these two angles. Why is AC congruent to AC? Hopefully you remember that's our reflexive. And then we know that ABC is congruent to CDA by side angle side. Okay, so now let's walk through this proof together. So we know EF is congruent to FG, and we know DF is congruent to FH. So I have two sides. Question is, can I get another side or an angle? Well, if we look at that diagram, hopefully you see that we have vertical angles. I know that angle D, oops, I'm writing badly. The angle DFE is congruent to angle HFG. And that's because vertical angles are congruent. And now if I look at that, I go blue, pink, green. So that is side angle side. So I have triangle DFE is congruent to triangle HFG. by side, angle, side. And again, like I said, we'll do these two proofs together tomorrow. If you have any questions, please note them down and ask me during class tomorrow.